Newton's first law is the law of inertia. Newton's first law states that if a body is at rest or moving at a constant speed in a straight line, it will remain at rest or moving in a straight line at constant speed unless it is acted upon by a force.
Why is it hard to push a stationary car?
As we know from experience, some objects have more inertia than others. It is obviously more difficult to change the motion of a larger object than the smaller one. The inertia of an object is measured by its mass. The more mass an object has, the greater force needed to change its motion.
Okay, go.
Then what about motorcycle?
For motorcycle, it is easier for us to push it because motorcycle has a smaller mass than the car. So we can conclude that the motorcycle inertia is lesser than the car.
When a moving car is suddenly stopped, why does the driver's body got pushed forward?
When the car comes to a sudden stop, the driver body tends to keep moving forward. That's why the driver body got pushed forward because of the inertia.
Guys, can you tell me what is the Newton's second law?
Sure, Fahmi. Newton's second law of motion states that force is equal to the product of the object's mass and its acceleration.
So how can we relate this to our daily life?
Do you wonder why when you push the car, it moves forward slowly, but when you push the motorcycle, which is significantly lighter than the car, the motorcycle moves forward faster? This is because, according to the Newton's second law of motion, mass is inversely proportional to the acceleration. So, the lighter the object, the higher the acceleration of the object. That is why you can push the motorcycle easily, but can hardly push the car.
So, in the next video, Hami, you can see that the boy is able to push the motorcycle to a certain point, but when his friends help him to push it, the same motorcycle moves even faster and further compared to when the boy pushed it by himself. So, this shows that the greater force produces greater acceleration. Thus, force is directly proportional to acceleration. And by those conclusions, we can form a formula of acceleration equal to force divided by mass, or A equal to F over m, which can be rearranged to F equal ma to find the magnitude of the net force.
The last Newton's law of motion is Newton's third law. Newton's third law states that when two bodies interact, they apply forces to one another that are equal in magnitude with opposite direction. The Newton's third law, also known as action-reaction forces. For every action applied on a body, there is a reaction that have the same magnitude but opposite direction.
When the car is moving with constant velocity, the magnitude of the force produced by the engine is equal to the magnitude of the friction force exerted on the tire.